For representing functions, we have to understand what a function is. A function is just a special kind of relation. It's a relation where for each value in the domain, there is only one value in the range. I can show this using a map easily. A relation would work with this as long as there are some lines going somewhere from left to right. But a function is where you can't have two arrows coming from the same x-coordinate. So a function could look like all straight lines, or it could even look something like this. As long as there's only one arrow coming from each x-coordinate. A relation that isn't a function would look like this. You can see that for this x1, there are two arrows coming from this point, and that just won't work for a function. If we look at a table, it's clear that this table, this relation, does not satisfy being a function if any of these x values occur more than once. All of the x values for coordinate pair have to be different for it to be a function. We'll go over what is or isn't a function more in detail in the examples. Functions are written in the form f of x. This f is just saying that it's a function we're calling f. We could also have a function g of x, or even h of x. You could really have anything you wanted to. You could use Greek letters, or words, anything. There's a huge convenience to this notation. So if I said this function of x was equal to, let's say, x squared minus 10x plus 2. If I wanted to know what the y value was at any point, I would just find the function at that point. Instead of looking it up in some table, I can just plug in an x value and calculate out the y value. If I wanted to make a table for this relation, which happens to be a function, that can be expressed like this, all I have to know is the x values. Whatever x values they want me to use, or just pick them myself, and then I can just calculate all of the y values, because it's just the function evaluated at x. This function notation is also very convenient when doing arithmetic. I could easily calculate f of 1 minus 2, all of this times 6. It's very easy to just write it in like that. But I could also do arithmetic inside the parentheses of this function. So if I had f of x, I can now ask you to find f of 2y minus 1. You would do that by plugging in 2y minus 1 to where x was formerly. So if your original function of x was 2x minus x squared, when you evaluate it at 2y minus 1, you would have 2 times 2y minus 1 minus 2y minus 1 squared. Anything that can be written like f of x equals some stuff that involves x's is a function. What this means is that if I said y equals 10x, I can easily represent that as a function by saying f of x equals 10x. Sometimes, though, this might take a little bit of algebra. For if xy equals 5, y would be 5 divided by x. And this is a function.